Well, almost 2 years ago, I built this battery charging station, but with time, I felt this project needed an upgrade. So I have designed a brand new tensile battery charging station with completely new design, more features, and much cleaner look. In this new version, I have used TP4056 charging module with both Type-C and Micro-USB variant, new SMD 1850 battery holders, XC60 connector, both male and female, and it can also charge mini lipo batteries, and it comes with real-time voltage monitor and total power consumption. So first of all, I designed the entire PCB, and as you can see, the layout is completely different from the older version. And after finalizing the design, I generated the Garo file, and it's time to order the PCBs.
For this project, I am going to order the PCB from JLC PCB as they have sponsored the PCB for this video. They offer premium quality PCB at a very affordable price, and the ordering process is extremely simple. All you need to do is upload the Garo file. After uploading, just select the quantity, choose the PCB color as I am going with blue, and keep the rest setting as default, then add it to cart and proceed to checkout.
Within 7 days, I received the PCBs, and honestly, the quality is excellent. Clean traces, perfect drill hole, accurate cutout for voltmeters and voltmeters. So without wasting time, let's start assembling. First, we need the TP4056 charging modules. Here I am using both Type-C and Micro-USB variants. I will place them on the PCB and solder them one by one. While soldering, make sure the pads and module pins are properly soldered. A weak solder joint can break if the PCB bends slightly, which may cause charging issues later. After soldering the charging modules, now I will add these 18650 battery holders. The reason I choose this holder is simple. They make it much easier to insert and remove batteries. They are more convenient than the through-hole holders that I've used in my previous version. Once soldering completed, it's time to add the BTR switches. These switches allow me to turn on or turn off each charging module individually. After placing them on the PCB, I solder them securely. Now I will add a 10-pin DIP switch, two 2-pin screw terminals, XC60 connector, both male and females, 2-pin GST connector for mini lipo batteries. After adding them into the board, I will solder all the connectors properly. Now it's time to add the voltmeter and voltmeter. So first I insert the voltmeter into its cutout. Then insert the voltmeter into its slot. After that, I connect the voltmeter wires and solder them to the PCB. I do the same for the voltmeter wires. Now our charging station is almost completed. Here I am using a second PCB as the back cover and using some M3 brass spacers and M3 bolts.
You can order this M3 brass spacers and nut and bolt kit from JLCMC, link in the video description.
I have also designed a custom back cover for it, so if you want, you can 3D print it and use it instead of the PCB. Now comes the moment of truth. after connecting it to a power supply, all the charging modules power up correctly and the voltmeter and voltmeter works perfectly. So now let's add the batteries. And before that, let me tell you something about our charging station. You can power this charging station using screw terminal or XC60 connector, but always remember the input supply is 5 volt. Anything higher can damage the charging modules. And before charging, let's check the voltage of each cells, and as you can see it's 4 volt, the second one is 3.5 volt, the third one is 4.1 volt, the fourth one is 4 volt and fifth one is 3.5 volt.
Since the voltage of each cell is different, so it's a perfect situation to test the functionality and efficiency of our charging station.
As I mentioned earlier, you can power it using screw terminal or XC60 connector. So here I'm using the XC60 connector and I have connected it to my power supply. And make sure your power supply should support at least 10 to 8 ampere current, otherwise charging will be slow and inefficient. And remember one thing, by charging through Type-C or Micro-USB, we can charge only 1 to 4 cells at a time. To charge all the 10 cells, always use screw terminal or XC60 connector as input. After 3 to 4 hours, all the batteries are fully charged. And yes, you can also charge mini lipo batteries using the first two charging modules or the last two charging modules.
And we can easily connect lipo batteries by simply plug into the JST connector. And as you can see, the battery charges smoothly.
So that's it for today's video. I hope you enjoy this new Tencel battery charging station. Let me know in the comment what feature should I add in the next upgrade, which design you like more, version 1 or version 2. And if you are looking for a small charging station, check out my 4-cell charging station video, link in the description. And if you enjoy this project and want to build your own, you can find the Garver file link in the video description. You can order the PCB from JLC PCB, and if you will join through my link, you will receive a $123 coupon. And don't forget to check out JLC PCB, link in the video description. Thanks for watching. Peace out.